The Substitution Method, Lesson 3.8, Part A. The standards are 8EE8, 8EE8B, and 8EE8C. The objective is to solve systems of equations algebraically. The essential question, why are graphs helpful? Steps on how to solve. Number 1, pick the equation that says x equals or y equals. Number 2, box and substitute. Number 3, solve for the variable. Number 4, plug the answer into an equation and solve for the other letter. Number 5, write your answer as a point x, y. The solution is always set up as x, y. I'm going to explain to you the idea of the substitution method. I have two equations, y equals x plus 2 and y equals 2x minus 1. So the y's are myself as the teacher, and then I have 2x minus 1, which is my substitute. So I can put this y up here, and it has not changed the equation. It's still the same thing. Now my substitute is going to take my place, which is the y, and it still has not changed the equation. But now I can solve this equation. Now I'm going to give you another example. Now I have x plus y equals 6 and x equals y plus 2. This time I am x as the teacher. My substitute is y plus 2. So if I put the x here, nothing has changed. Still the same equation. Now I'm going to take my substitute and put it where x is. Still the same thing, but now I can solve this equation. Now I'm going to give you one more example. I have x minus y equals 4 and y equals 2 minus 5x. So this time I am y. My substitute is 2 minus 5x. So where the y is, I'm going to replace it with 2 minus 5x. The only thing I have to add is parentheses in front of 2 minus 5x, and then I can solve this equation. Example number 1. Solve by substitution. Y equals x plus 4 and y equals 2. So what I'm going to do is box in what y equals. Y equals 2, so I'm going to box in the 2, and I'm going to box in the y in the first equation. So now I'm going to substitute. Where the y is, I'm going to replace it with the 2. So I have 2 equals x plus 4. I want to solve for x, so I'm going to move the 4 to the other side by subtracting both sides by negative 4. This side will cancel out. I'm going to bring down x equals 2 minus 4 gives me a negative 2. I don't have to plug anything into the equation because they already gave me the answer to y. So my answer is x is negative 2 and y is positive 2. So the solution to this system of equations is negative 2, 2. Example number 2. Solve by substitution. Y equals x minus 6 and y equals 3x. So I'm going to go ahead and box in what y equals, and I know that y equals 3x. And in the first equation, I'm going to box in y. So wherever there's a y, I'm going to replace it with a 3x. So I have 3x equals x minus 6. Now I'm going to solve for x. So I need to move the x on the right to the left by doing the inverse. So I'm going to subtract x from both sides. This side will cancel out. 3x minus x will give me 2x equals, bring down negative 6. So I'm going to go ahead and divide both sides by 2 to isolate x. This side will cancel out. X equals negative 6 divided by 2 gives me a negative 3. So I know that x equals negative 3. Now we're going to solve for y. I'm going to rewrite my equation. Y equals x minus 6. Since we already solved for x, and that's negative 3, wherever there's an x, I'm going to replace it with negative 3. So I have y equals negative 3 and bring down negative 6. So I have y equals negative 3 plus a negative 6 gives me a negative 9. That means y equals negative 9. So the solution to this system of equations is negative 3, negative 9. Example number 3. Solve by substitution. Y equals 2x plus 1 and 3x plus 4y equals 26. So in the first equation, I know that y equals 2x plus 1, so that's what I'm going to box in. In the second equation, I'm going to box in y. So wherever there's a y, I'm going to replace it with 2x plus 1. So I'm going to go ahead and rewrite the second equation. I have 3x plus 4. Now instead of writing y, I'm going to replace it with 2x plus 1 equals 26. So I'm going to go ahead and distribute first here and here. So I'm going to bring down 3x plus 4 times 2x is 8x. 4 times 1 is positive 4 equals 26. I'm going to combine my terms, 3x and 8x. That's going to give me 11x. Bring down plus 4 equals 26. Now I'm going to move the 4 to the right. So I'm going to do the inverse. So I'm going to subtract 4 from both sides. This will cancel out. I'm going to bring down 11x equals 26 minus 4 will give me 22. Now I'm going to divide both sides by 11. This will cancel out. X equals 22 divided by 11 will give me 2. So I know that x equals 2. Now I'm going to rewrite my first equation. I have y equals 2x plus 1. Now I can plug this into either equation, but the first one is easier. So wherever there's an x, I'm going to replace it with a 2. So I have y equals 2 times 2 plus 1. So I have y equals 2 times 2 is 4 plus 1. So y equals 4 plus 1 is 5. So y equals 5. So the solution to this system of equations is 2, 5. Example number 4. Solve by substitution. 2x plus 5y equals 44 and y equals 6x minus 4. So I notice that in the second equation, they already solved for y, which is 6x minus 4, so I'm going to box it in. And I'm going to box in y in the first equation. So wherever there is a y, I'm going to replace it with 6x minus 4. So I'm going to rewrite the first equation, which is 2x plus 5. Now instead of y, I'm going to write 6x minus 4 equals 44. I'm going to distribute here and here. So I'm going to bring down 2x. And then 5 times 6x will give me a positive 30x. 5 times negative 4 will give me negative 20. And then bring down 44. I'm going to combine my like terms. So I'm going to combine 2x and 30x. That gives me 32x. Bring down negative 20. And bring down 44. So now I need to move the negative 20 to the right. So I'm going to do the inverse, which is addition. So I'm going to add 20 to both sides. So this side will cancel out. I'm going to bring down 32x equals 44 plus 20 will give me 64. I'm going to divide both sides by 32 so I can isolate x. This side will cancel out. X equals 64 divided by 32 will give me 2. That means x equals 2. Now I'm going to rewrite the second equation, which is y equals 6x minus 4. Now I could have plugged it into either equation, but the second one is easier. So wherever there's an x, I'm going to replace it with a 2. So I have y equals 6 times 2 minus 4. So y equals 6 times 2 is 12. Bring down negative 4. So y equals 12 minus 4 is 8. So y equals 8. So the solution to this system of equations is 2, 8. Sometimes we will have special cases. That's when the variables cancel out. Sometimes we will end up with no solution or infinite solutions. So in no solution, we have parallel lines where a number does not equal a number. For instance, 5 does not equal 10. Or we will have infinite solutions. That's when the lines are on top of each other. That's when we have a number that equals a number. Like 0 equals 0 or 5 equals 5.